Okay, so here we have the Varsi T set up in ISO. We have a transformer, primary connected to A, secondary connected to B, and we have it connected to a makeshift 8 ohm load. Then we come over here and we have a signal generator that we're going to change the frequency of. And over here on channel B, we have the output of this scope, and we can see that peak to peak it's reading 500 millivolts. So what we're going to do is check the frequency response of this transformer by adjusting the frequency, and when that voltage goes down to 0.7 of 500 millivolts, which is about 350 millivolts, that's the 3 dB bandwidth minimum of the pass frequency. So we're going to go ahead and do that. And we're also monitoring this is our input voltage at 2.24 at 1000 kilohertz. And the frequency is going to change, but the voltage we don't want to change because that would be the bandwidth of our signal generator. So let's get you set up here. And we're looking at the scope, and we're looking at the output voltage as we change the frequency. So we're going to go down first. Till that goes down to 350 millivolts. Right there you can see it starts distorting. So that's about the lowest bandwidth before you start getting distortion. And on our frequency generator, that's at 60 hertz. Now we're going to go the other way. So right there we get about 350, and we're at 77 kilohertz. So for audio frequencies, 77 kilohertz, and our cyclic RMS on the input is still at 2.24 volts. So that's a pretty good transformer. So we're back to normal, and remember that 0.7 of peak to peak, we have 500 for peak to peak, so 0.7 at peak to peak was 350 millivolts, and that's what we were looking for, and we got that at about 77K. So as far as using this transformer in a circuit, I would have no problem. And just to clarify, this was the setup that we used: the signal generator into the A ports, into the primary. The secondary was tied to the 8 ohm resistor and the scope. So here's our setup for the crossover. We have the signal generator hooked up to the input of the crossover. We're going to be looking at the woofer or the bass speaker output first, and then we're going to look at the tweeter output. So right now both of these outputs have 4 ohm resistors across their outputs, and the scope is tied to B. And we've set the output voltage up here to 500 millivolts. So we're going to do basically the same check we did, and you can see our resistive loads are right here connected to the ports shown on the page. All right, so we're going to change the output by tens until that goes down to 350 millivolts. So right about there, and that's about 100 hertz. So the low end of this crossover frequency so there it drops way below 320, 344, right in there. That's about 100 hertz. 90 to 100 hertz is the lower end. And let's go up to the higher end. Right now we're at 2K and we're starting to drop. Right there is 2.5K. So it looks like we're good from 90 is where we start dropping off to 2.5K. All right, so right now we're on the tweeter output, and we can see at 1,000 hertz we don't have a whole lot there. So we're going to increase that till we get to the 3 dB bandwidth. Which is about right there. Somewhere around 350. And the tweeter picks up at about 2.3K. And we're going to run that up. So we still got over 400 at about 16K. Stays pretty stable right at that 70% point. And I'm up above 22K. So figure, you know, that bandwidth goes from about 2.3K up to 22K on the tweeter. And I got a bunch of noise, probably because of I'm picking it up on these resistors and the lines going to the resistors on the tweeter side. But that's basically it. So just to summarize what we've done in the last two steps, we had our signal generator hooked up to our transformer primary on the A jacks. Then on the B jacks, we had the secondary with an 8 ohm resistor across it attached to a scope. With our output set to 500 millivolts at 1,000 hertz peak to peak, we looked for the 3 dB drop, which was approximately 0.7 times 500 millivolts gives you about 350 millivolts. So that occurred at about 60 hertz. So this transformer was good from 60 hertz to well above 20 kilohertz, which is above our hearing range. So this transformer was really good. On the crossover test, we hooked the signal generator up to the input. We had a 4 ohm resistor across the base output, and we looked for we set our voltage at 500 millivolts peak to peak, and again we looked for 350 millivolts, which would be about the 3 dB point. So that occurred at 90, and then we made it up to about 2.5K. I'm sorry, I got this dot in the wrong place. And at 2.5K, it was 3 dB down. So our bandwidth on the woofer was 90 hertz to 2.5K hertz. Then we went over and moved the scope up to the tweeter, okay? And we picked up the 3 dB point was at right here at about, or I'm sorry, the 3 dB point was at about 2.3 kilohertz, which would be about right there. So from 2.3 kilohertz all the way up to over 22 kilohertz, the output remained constant. So the pass of this crossover point was somewhere around 2.3 to 2.5K. That would have been the mid bandwidth where the woofer started dropping off and the tweeter started picking up. So that was our crossover test.